Systems of linear equations guided notes. Next time we'll work on systems of inequalities. Two or more linear equations that use the same variables forms a system of equations. The solution to a system of linear equations is the ordered pair. So remember, an ordered pair is x comma y in parentheses. That makes the equations in the system true. When a system of linear equations is graphed, we can find the solution to the system by looking at the point of intersection, so where they cross. When solving a system of equations by graphing, it's often easiest if both equations are written in slope-intercept form. In A and B below, graph to solve the system, then answer the two questions at the bottom, A and B. So in A, we have a system. Remember, a system of equations means two or more equations. So our first equation is y equals 2x minus 1. That's already in slope-intercept form. And then our second equation is negative 4x plus 2y equals 4. We have to make sure that both of these equations are in slope-intercept form. The first one is already in slope-intercept form, so we can leave that one alone and graph it. The second one is in standard form, so we have to get it into slope-intercept form. There is a video posted in Google Classroom about getting the equation in slope-intercept form using Desmos. So that method is called the MDR method. So if you do not know the MDR method, you can go to Google Classroom and watch that video. So our first equation, y equals 2x minus 1, I'm going to graph that one in green. Once I put it in Desmos, I saw that I had a y-intercept of negative 1, and then I had another point at 2, 3. And I'm just going to connect those. So that's my first line. My second line I'm going to make red, and that one is in standard form. So make sure you go watch the video in Google Classroom and get it into slope-intercept form. So I have negative 4x plus 2y equals 4. Once I graph that in Desmos, I have an x-intercept at negative 1 and a y-intercept at 2. You don't always have to use the intercepts, but I like to use them. I like to look at the intercepts first if I'm going to graph on paper. Remember, you have to have two good points in order to graph them. All right, so I have graphed my two equations. As you can see, they're parallel lines. With parallel lines, they don't cross, they don't touch, they don't intersect, none of that. They're parallel, and when you have two parallel lines, that means your solution to the system is infinite. So down here, when it says, what did you notice about the lines? What did you notice about the lines in A? What does that mean? We notice that the lines are parallel and that there's no solution. No solution. And then for B, our two equations are y equals negative x minus 2, and our second equation is 6x plus 6y equals negative 12. So we're going to put both of these in Desmos. Remember, this second equation, which I'm going to make red, is in standard form. So you need to go to Google Classroom, watch the MDR method video, and then put it in slope-intercept form. So the first equation, y equals negative x minus 2. We're going to graph that. We have an x-intercept of negative 2. And let's see if we have a y-intercept. A y-intercept of negative 2. So we're just going to plot those 2 points and then draw a line to graph them. All right, now the second one, that's in standard form. You have to get it into slope-intercept form in Desmos, or it's not going to graph for you. So we got 6x plus 6y equals negative 12. For this line, it looks like they're right on top of each other. So again, I have an x-intercept of -2 and a y-intercept of -2. Once I draw those lines, we can see that those lines are right on top of each other. So when we answer the question at the bottom, what did you notice about the lines in B? I noticed that the lines are the same. The lines are the same. And when you have two lines that are right on top of each other, that means you have infinitely many solutions. Infinitely many solutions means every point on one line is exactly the same point on the other line. So all of the points are going to match up, and those lines are going to infinity. So all of those lines on the top one, the green one, they match the red one. All right, so the following types of solutions are possible when solving a system of linear equations. You can only have these three types of solutions. You can have one solution where the lines cross at one point. That means that the lines have different slopes and intersect at one point. When the lines are parallel, like these, and they don't cross at all, then you have no solution. No solution lines are lines that have the same slope and different y-intercepts. They do not intersect. I want you to write parallel down here. And then when the lines are right on top of each other, or it looks like you only have one line in your Desmos or on your graphing paper, that's infinitely many solutions. The lines have the same slope and the same y-intercept because those lines are exactly the same. We have multiple ways of solving systems of equations and inequalities. Our first way that we just talked about is by graphing. Now the second way is by substitution. So when you substitute, you're just going to be taking one of the variables and plugging it into the other equation. So the steps for solving by substitution. The steps to solving systems by substitution are basically solve, substitute, and then you can check your answer. But you would solve one of the equations for y, then you would substitute that value for y into your second equation, and then solve the new equation to find x, then substitute that value back in to either of the original equations and to find y. So it's a little confusing just listening to the steps, but if I show you, you'll probably get the picture. So we're gonna solve one of the equations for y. It says if necessary. So let's look at number 1. In number 1, we have 7x plus y equals 12. That's in standard form. And then we have y equals 4x minus 21. That's in slope-intercept form. Okay, so the first thing we're gonna do is solve for y. This second equation in number 1 is already in slope-intercept form, so we already have it solved for y. So we're going to use that y value. Let's circle it. We're going to use this y value, which is just 4x minus 21, and we're going to plug it in to the top equation and try to solve for x. So we're using what they gave us for y equals. We're going to plug it in for y, and now we're going to try to solve for x. So our equation is 7x plus y. But instead of y, we're going to put 7x plus y is 4x minus 21. And then we put the rest of the top equation, equals 12. Now we're trying to solve for x. I put the parentheses here because sometimes it's not plus. Sometimes it's a negative or minus. If this was a minus here, then we would have to distribute the negative to everything inside the parentheses. But right now we're basically distributing the positive or multiplying by 1. So since this is a positive right here, we're basically distributing 1 into the parentheses, which does not change the value. So we have 7x plus 4x minus 21. The next step, equals 12. The next step would be to combine like terms. 7x and 4x are our like terms. 7 plus 4 is 11, which makes it 11x minus 21 equals 12. I'm solving for x, so I want everything away from x. So I'm going to move this positive 21 to the other side of the equal sign by doing the opposite, which is plus 21. So now I have 11x. The negative 21, positive 21 canceled out. So I'm just left with 11x equals 33. I'm going to drag this over here so we can have more space. So basically I have 11x equals 33. Now I'm still solving for x. Right now, x is married to 11. 11x means 11 times x. So in order for me to divorce them, I have to divide by 11. 11 divided by 11 is just 1. So I just have 1x. 33 divided by 11 is 3. So that means x equals 3. You don't have to write this 1. I just wrote it so that you understand a number divided by itself is 1. So right now, we solved for y, which was right here. We substituted the y value in and solved for x. And now we're going to substitute the x value back into either one of these equations in order to get y. Because remember, a solution is an ordered pair. So we're going to use the x value that we just solved, so x equals 3, and we're going to plug it in to the second equation. Let's use the second equation. It doesn't matter which one you use, but I'm going to use the second equation, and I'm going to now write in green. So I have y equals 4x, which is 4 times 3 minus 21. 4 times 3 is 12. 12 minus 21 is negative 9. So y equals negative 9. That means my ordered pair is 3 comma negative 9. This is my final answer, 3 comma negative 9. So let's do the second example. For the second one, it's the exact same thing. We have two equations, which makes our system. This bottom equation is already written in slope-intercept form, so I don't have to do the first step and solve for y because it's already solved. So we're going to take this y value and plug it into this y value right here. That gives us 2x plus 3 times negative 6x minus 2 equals 18. We distribute the 3 to everything inside the parentheses. So I have 2x, because I didn't do anything with that. And then 3 times negative 6 is negative 18x. 3 times negative 2 is a negative 6 equals 18. The two terms that I can combine here are 2x and negative 18x, which makes negative 16x minus 6 equals 18. Oh, sorry. Yeah, equals 18. And then I'm moving everything away from x. So I want to move this negative 6 to the other side of the equal sign by doing the opposite, which will be plus 6. Negative 6 plus 6 cancels out on the left side, so I'm just left with negative 16x equals 24. Now I'm divorcing negative 16 from x. They're getting a divorce. So I'm going to divide negative 16 both sides. So negative 16 divided by negative 16 is just 1x. 24 divided by negative 16 is a negative 1.5. So my x value is negative 1.5. Now we're going to take this x value and plug it back into either one of the equations. I like to use the second one because it's in slope-intercept form and it makes it easier. Because now I'm solving for y. So it'll be easier to use something that already has y equals. So I'm going to put, let's use green. Y equals negative 6 times negative 1.5 minus 2. Negative 6 times negative 1.5 is a positive 9. 9 minus 2 is 7. So y equals 7. So my point is negative 1.5 comma 7. And remember, you can always check these with Desmos. So the graphing that we did in the first part, in part A and B, you can do that to check your answers. So let me box my final answer in red. All right. Oh, this was already written. Okay, well, I'm just going to keep it like that. All right, so the next way we can solve linear systems of linear equations is by elimination. So to solve by elimination, you would use these steps. You would line up the like terms, add the equations to eliminate the variable with opposite coefficients, and then solve for the remaining variable. After you solve for that remaining variable, you substitute. So we're back to substitution. You substitute the value of the known variable into either of the equations that you have in order to solve for the second variable. So when you eliminate, it'll be pretty easy to identify. So let's look at number 1. Number 1, we have 3x plus 2y equals 16, and we have negative 3x plus 4y equals 14. We want to eliminate one of these variables. Eliminating it means we're making it 0. So you're going to line up the like terms, which is already done, and then we add the equation. For number 1, we already have the equations lined up, and what we mean by lined up is the x terms are lined up right on top of each other, and the y terms are lined up right on top of each other. We add them together, we're combining them. So when we have a positive 3x minus 3x, that gives us 0. So it cancels out. So this cancels out. That's what we mean by elimination. We're eliminating one whole variable to solve for the other one. So in number 1, we are eliminating x to solve for y. So now we're going to still combine like terms. Now we're combining 2y plus 4y, which is 6y, wrong color. 6y equals 16 plus 14 is 30. Divide both sides by 6. Y equals 5. Now we're going to plug in y equals 5 into either one of those equations in order to solve for x. I'm just going to use the top one because they're all positive. So I have 3x plus 2y. But instead of y, you would write 5 because y is 5. We already solved for it. So now I'm solving for x. 3x stayed, nothing happened to it. 2 times 5 is 10, equals 16. I'm going to subtract 10 from both sides because we're doing the opposite to move it. Now I'm just left with 3x on the left side equals positive 6. Divide both sides by 3, x equals 2. So my point, my ordered pair, which is my solution to my system, is 2, 5. Okay, and let's do the same thing to the second one. Number 2, we have 7x plus y equals negative 2, and 3x minus y equals 12. I don't know if you guys noticed, but when you solve by substitution, one of the equations is already as y equals. So that makes it easy to see if you should solve by substitution or not. But for elimination, both are in standard form. So if you happen to solve by hand, if you see both of the equations in standard form, you should use elimination. But if you see one of the equations in slope-intercept form and one in standard form, then you should solve by substitution. Or you can solve by graphing and go the easy way. All right, so we're going to eliminate. It's easy to see that we are eliminating y because a positive y minus y is 0. So we're eliminating that, and we're just left with 7x plus 3, which is 10x, equals negative 2 plus 12 is positive 10. Divide both sides by 10. X is 1. Now I'm going to use that value and plug it in. I'm going to plug it into, let's do the top equation again. So I'm going to, instead of 7x, I'm going to write 7 times 1 plus y equals negative 2. We're plugging in x in order to solve for y. As you can see, y is my only variable, in this equation? Because I just plugged in 1 for x. So 7 times 1 is 7 plus y equals -2. I'm moving the 7 over to the other side of the equal sign because I want to get y by itself. So this is a positive 7. I'm going to move it by doing the opposite, which is -7. 7 minus 7 is 0. So I'm just left with a positive y on the left. -2 minus 9 is -2 minus 7 is -9. So y is -9. X is 1. That means my point is 1, -9. And remember, you can always put this in Desmos to check your answer. All right, finish these notes. Make sure you tape it in your interactive notebook on your next available page, and the title is right here. You have to write the title in your notebook and then glue these notes down. Make sure you update your table of contents for our next notebook check.